Hi friends, welcome to the channel Programming in Python with RSK. Friends, in this video I will be explaining list in Python. This is the first video on the list. Two more videos on this topic I will be uploading shortly. The topic is too big to be covered in single presentation. So let us start our presentation. List is an entity which can hold values of different types under one identifier or under one name. It can hold different values, multiple values, and those values can be of different data types. So in one list we can include a string or and a int and a float constant and any other constant that is available in Python. In programming context, generally it is used to hold values of same type. There is no rule, it is just a practice followed by programmers. It resembles, the list resembles an array in C or any other language. In C or C++, an array can hold multiple values of same data type. Only difference with list is it can hold multiple data of multiple types. In Python context, list is a ordered, mutable and iterable collection of multiple data of multiple types. Why it is ordered? Because the values that we insert in a list appear in the same order of insertion. It is a mutable collection. The value in a list can be changed during runtime, during the runtime of the program. So if we declare a list at compile time or in our script of the program, when that program gets compiled, there can be a set of values, say XYZ in a list. During the program we can change the values at locations which are occupying X value, Y and Z in the list by any other value of our requirement. So it is a mutable, we can change the list, contents of a list. Also we can iterate through a list using index. So it is called a iterable collection. How lists differ from those in arrays in C is a list can be expanded or shrinked during execution of the program, and hence also it is also known as a dynamic array. We can see in most of the classic arrays we cannot add a value or we cannot expand an array by adding additional values, or we cannot shrink an array by removing few of the values, because the main reason is the memory management. In most of the languages or previous languages which are type C or some C++ and all, once an array is declared, and defined. Compiler allots certain certain memory to it. Say certain memory locations, say 40 locations has been allocated. If we try to add another value, it will need more memory locations to accommodate that value in that particular array. Unless we provide for the addition or deletion of a content of an array through memory management functions, the program becomes unstable. But in case of lists, even if we add or delete or make certain changes in the total array content or total list content, the compiler and the Python takes care of all the energy management. We need not bother about it programmatically. How to declare and define and access values in a list, that we see here. We have declared fruits as a list containing these values: string oranges, a number 150, int constant 150, and so on. We can see to create a collection as a list and assign it to some identifier. All the values that we want to include in that list should be enclosed within a square bracket, and each value is separated by a comma. We can access a list using a for loop or some few other methods that we will see later on. In this case, for I in range 0 to 6, print fruits I. So I represents 0 to 6 because there are 6 values in this array, in this list fruits. Element of the array, elements of the list are being accessed using index. So 0 represents the first value in the list, oranges here. 6 will represent fifth value, because when for loop runs, the loop will execute up to 5, and on reaching I equal to 6, the loop will terminate. So what we get is, we have accessed using a for loop all the values that have been assigned to fruits. We can also access individual value by mentioning its index. So here fruits 2 and fruits index 3 we are accessing, so we get mangoes and 200 as the output. There is one more feature of Python. If you want to fill up a list, or if you want to assign same value multiple times to a list, we can do it like this. A list with a value 3.14, and I want to multiply this value, or I want that multiple values of the same constant 3.14 should populate my list named enum. So that is possible. We can see just by this multiple star sign and constant 10, 3.14 has been assigned to list enum 10 times. Same with strings, Python list with Python as the values. How many times? 5 times, because here I have mentioned 5. We can also empty a list. Now enum consists 10 values, whatever 3.14. When we assign that enum with empty brackets, all the data in the list enum will be deleted. Simpler way of displaying contents of a list, just print and in the bracket flowers, the name of the list, will give us the output indicating all the elements of list flowers. Same with numbers, num is equal to 1 to 10. My statement is print into the bracket num, and this will give me the output displaying all the contents of list num. Just enter the name. There is an identity operator is in Python. What it does is, it tells whether the identifiers are referring to the same object. In case of basic variables, int, float, complex, etc., when a value is assigned to an identifier, it creates an object, and that identifier refers to that object in our program. If multiple identifiers are assigned with the same value of int, float or complex or other basic variable, each identifier refers to the same object. Only one object is created in such cases. So when A is equal to 10, B is equal to 10, and when we give print A is B, we get output true, because A and B are the identifiers referring to the same object. We can see here ID of A and ID of B are same. If we assign A to another third identifier C as a list identifier and give a print A is C statement, we again get true output. In case of other collections or variables in Python, this is a bit different. Different lists, when created with the same values, then each list will have its own object created. When lists defined with the same values but bounded to multiple identifiers, multiple objects are created. In case of basic variables, if the value is same and if we assign that value to different identifiers, the object remains same. The identifier referring to that object may be different. In case of lists, each identifier having a assigned with a list is having its own object. Now suppose L1 is a list I created with values 11, 12, 13, 14, 15 and 16, and I create another list L2 with the same values. what I get is print L1 is L2, give me a output as false, because both L1 and L2 are two different objects. L1 refers to one object, L2 refers to another object. So L1 is L2 gives us a result false. We can see ID1 by printing ID of L1 and L2, both these IDs are different. L1 and L2 are of the same values, however two different objects are created. But it changes a bit when we assign one list to another using assignment symbol L1 is equal to L2. Now L1 and L2 refer to the same object, and hence L1 is L2 gives us a output true. If we will check the IDs of both L1 and L2, they are the same. So L1 creates one object, and when we assign L2 with L1, the same object remains same, but L1 and L2 becomes two identifiers referring to the same object. Only identifiers are different, object is the same. So what we can understand from this program is, on creation of multiple lists through assignment, no new object is created. All such identifiers which have been assigned with lists using assignment statement of assigning one list to another, all such identifiers refer to the same object. We can add an item to a list. When we try to add in a simple way, it fails. There is a list named fruits. It gives me output of, when I use print fruits for 5, I expect the output to be 123.5. When I want to add sixth object or seventh object at index 6 as strawberries, and I try to run the program, I get list assignment index out of range. So what it means is, once the list is defined, the number of elements of that list remain the same. We cannot add another element or additional element to that list. Why this is happening, that we will see. But how can we add? I want to add another object in this list fruits. That I can do by appending the fruits list, adding strawberries as another list, and I am adding strawberries list having a strawberries as its content. We create a list which now shows the additional object added, but the difference is fruits with these 6 elements has an object which ID is 1392. As soon as we add another value to the list fruits by using plus sign, the items get added into the list fruits, but a new object is created and the old object is no more available for reference, as the fruits refer to new object, and then the addition takes place. Changing elements of a list is possible. We cannot add a new value or a new constant or a new int or float or other variable to a list simply using index, but we can change the list using index. Now fruits 3 is equal to strawberries. This is what I am doing. The item appearing at index 3, which is 200, will be replaced by strawberries now. Replaces 200 in original list by strawberries, and we get the output where 200 has been replaced by strawberries. We cannot add additional elements in a defined list programmatically, but value of an element can be changed. There is a list 1, 2, 3, 4 up to 7. Its ID is given as ending with 9040. Now I change the value of third element or index 3, value at index 3, which is the fourth element in the list, with 1000. So what I get is a new list with 1000 occupying the position of index 3. In both cases we have given print ID statements, and what we find is, in case of replacing a object, replacing a value from the list or some element of the list, the replacement does take place, but object referred by that particular name remain the same. The object doesn't change. List changes, object doesn't change. Contents change, object remain the same. We can change multiple elements in the list. Now in this program we can see we have again the same fruits list. I want to replace all the elements starting from 2 to 4 or 2 to 5 excluding 5 by bananas. So I can write fruits 2 colon 5 into the square bracket and write whatever are the replacement items into square bracket and assign that replacement items to fruits 2, 5. What I get is the whole 3 values at index 2, 3, 4 are now changed to whatever we have given, bananas in this case. We can delete a list or empty a list. First we have declared a list or we have defined a list fruits. Its ID I have taken out. When I assign empty list to the list fruits, what I get output is a empty list, but now that empty list is referring to different object. So a empty list object is created which starts referring to the same identifier fruits in this case, we get a empty list, different object. We can nest and embed a list into another list. Two lists, num and num1. I can add num and num1 using this num2 is equal to another list num comma num1, and when I display that list, what I get is list num and list num1 becoming the members of num num2, but one list num which we are added to num2 is occupying 0th index of list num2, and num1 occupies index 1 of num2. So two different lists are clubbed together. This is analogous to a two-dimensional array in C. That we can see here when we give a print statement with num2 index 0, 3, what we get is 0th element of num2, which is a list num, and its element number 3. So the value here appears is 4. So what we get is 4 as the value. Similarly, for num2 indexed at 1 and 2, num2 index 1 is pointing to a list which is num1 we have added or nested, and 2 is the element number 2 of num2 num1, which is 7. So we get output 4 and 7 from this print statement. Num2 index 0 and 3 tells us that 0th element of num2 is num containing values 1, 2, 3, 4, 5, and third element of num is yielded when we refer num2 index at 0 and 3. Similarly, num2 1, 3 refers to list num1, which is now become a element number 1 of num2 and yields 7 as the output. We can embed a list into another list. This is the way. Num is 1, 2, 3, 4, 5. Num1 is 5, 6. Second place in the list is now taken by num, a list totally different list altogether, but it becomes a part of num1, and then we have given 7 and 8. So num1 becomes a list having contents 5, 6 and a whole list called num and contains 7 and 8. So when we print the list, it appears as 5, 6, then a whole list 1, 2, 3, 4, 5, which occupies index 2 of num1, and then 7 and 8. So this is 5 is index 0, 6 is index 1. The whole list num is index 2, 7 is index 3 and 8 is index 4. So when we give print num1 index 2, we get the whole list which has been embedded in num2, num1. Print num1 3. What will we get? 7, because that is the third element of num1. Whole embedded list is positioned at index number 2. There is another operator which unpacks a list, and that we can see through this program. I declared a string called S having content love Python, and when we give S1 as another identifier for a string and equate it or assign it with star of S, what we get is a unpacked string, each character in the string appearing as a independent character and all those independent characters separated by comma. So what star does is it unpacks each and every character of S. We can see here there is a space between love and Python. So that space also appears as a element of S1. Then we embed num with contents 1, 2, 3, 4, 5 into another list num1, but with unpacked. So what we get is a regular unpacked list num1, where the list num and its contents are appearing at number 2 index of num1, but not as a list but as a independent character or independent number. If we give a statement print num1 and index 2, what we get is 1. Now what we understand from this is, when unpacked list is embedded in another list, the contents occupy the position at the index at which we have embedded a new list and unpacked it, but instead of that list appearing as a one entity or one value in the list in which we have embedded that second list, it unpacks and occupies the items with progressive index positions in the embedded list. We can concatenate, merge and search using in operator. So num is equal to this, num is equal to num plus another list 60, 70, 80, 90 are its contents. What we get is a new list with all these 4 contents occupying their respective indexed position. This is called concatenation. Two lists are concatenated. Then there are two lists again, num and num1 with these values. Num2 we create third list num2 and concatenate num and num1 and then print num2. So what we get is a new list where the values of the two lists are merged and a new list is available. It is called merging. We can find the content of a list using a in operator. Now what we are doing here is find is equal to 40 in num. Our list num contains 40. So what we get is true. Find is assigned with true because 40 is a content or is a member of list num. Then we try to find out 50 in num1. Num1 contains 100, 200 and all. So definitely 50 is not there. So we get an output false. We give another statement 500, print 500 in num2. Since num1 and num2, num and num1 create num2 and num1 contains 500 as its element, we get a output as true. What we are actually demonstrating here is we can use the operator in for searching a list. How in works, that we will see in our next video. We can compare lists using comparison operators. A is equal to 460 and all. This is one list. BB is another list. And what we give a statement, print AA is less than BB. We get the output as false. See the peculiarity here. AA's element 0 is 4, BB's element 0 is 3. Similarly 60, 59. These two elements are having values 4 and 60 which are greater than respective indexed values in BB which are 3 and 59. So as this 4 is not less than 3, we immediately get a output false. Python compares lists elements by element and looks for the difference in element values. It will compare in the first comparison itself. When it compares 4 with 3, AA is less than BB becomes false. It will not search further elements. It cannot. We can see here element number 2, 3, 4 of AA are really having a less value or less than 105, 205 and 6. But at the first instance, when it finds that AA is less than BB for the element number 0 and 0 of AA and BB, the output is false and it stops the search. It compares the first element. If they are equal, compare the second element. This continues until difference is found. If there is no difference, then the output will be true. If one list ends before a difference is found, the shorter list is considered smaller. Now see here, A is equal to 460, BB is 3, this. Print AA greater than BB. So it will be true because 4 is greater than 3. A is 100, 200, 300. BB is 3 having 5 elements. AA is having 3 elements. If we compare AA with BB, we get true because 100 is greater than 3 and comparison ends there. It doesn't further finds whether other elements, what is there, whether they are equal or lesser or greater than each other. So this is all about simple concepts of list. Thank you for watching. In my next video, I will be explaining the functions or the built-in functions of list. Thank you very much. Please like, share and subscribe the channel. I also have another channel, Programming in C with RSK, where there are more than 55 videos explaining each and every aspect of C language. Request all of you to please subscribe to that channel also.